1.1, understanding points, lines, and planes. Understanding points, lines, and planes. Okay, so understanding points, lines, and planes. Let's go ahead and open up your book. Oh, by the way, has everybody gotten the book? Everybody got a book, correct? Is anybody there who has not gotten the book yet? Okay, I'm not hearing anything, so I'm assuming that everybody's got a book. Okay, so let's go to page 6. Undefined terms. These are terms, are the most basic figures in geometry are undefined terms, which cannot be defined by using other figures. Okay, in other words, these are the building blocks of geometry. Okay. Undefined terms, in the middle of the book, it says a point names a location, has no size, and is represented by a dot. Okay, so I have a point P. Okay, obviously not all points are labeled P, but this point I'm labeling as P. I could have labeled this as point T. Okay, but anyway, that's how we look at it. That's how we label a point. Okay, it is labeled with a capital letter. In a diagram, it looks like that. A line is a straight path that has no thickness and extends forever. Forever. So if I have T and I have S, I can have a line that goes like this on either direction. And the line is labeled as this or as this. In other words, the order of this does not really matter. They're the same. Okay. We will talk later pretty quickly about a thing called a ray. When we talk about a ray, there is an order, but for a line, there really is no order. Okay, there is no order. Okay, which kind of makes sense. You'd have to have 2 points to define a line, right? Okay. So on line, there's obviously infinite amount of points, but to actually define a line, or you would go ahead, you would have to have 2 points. Okay. By the same token, to define a plane, okay, you would have to have 3 points. You would have to have 3 points to define a plane, however, whatever plane you're talking about here, okay? So we call these 3 points, we call them coplanar points. In other words, they are 3 points that are in the same plane, coplanar, okay? Coplanar points, okay? A point. So on the undefined terms, the bottom one, it says, a plane is a flat surface that has no thickness, extends forever. A script, capital letter, or 3 points, not on a line. Why does it say that the 3 points cannot be on a line? Okay? If I had 3 points on a line, A, B, and C, I could have infinite amount of planes in this line. Can you see that I can have a plane? If I had the 3 lines, three points that are on a line, I could have many different planes, right? I could have infinite amount of planes on those lines, right? Across that goes to that line. Okay. So that's why the 3 lines have to be not on a line. Okay, they cannot be on a line. In other words, they are supposed to be non-collinear. Okay. we'll talk about it later. Okay? So those are the 3 points. You need 2 points to make a line, 3 points to make a plane, or define a line and define a plane. Example 1, bottom of page 6. Refer to the design in the roof of Beijing's National Stadium. A, name 4 coplanar points. Name 4 coplanar points. So I need 4 points that share the same plane. And they are K, L, M, and N. Okay? In the middle there is that funky looking R which denotes the same plane. Okay? B, name 3 lines. The 3 lines that they named were AB, BC, CA. They could have named LM, MN, whatever it may be, right? Okay. Those are just 3 examples of them. Okay. Moving on to top of page 7. Top of page 7, it says segments and rays. Segment. A segment or line segment is part of a line consisting of 2 points and all points between them. So earlier, when we had T and S, we said that the line is this, okay? Or it was this, okay? And here we're talking about a line segment. We're looking at a segment between T and S. Between T and S, we're going to go ahead and notate that like this. In other words, it looks like this, but it does not have the arrows on both sides. So it's a segment. It means just this segment from T to S. Okay, just this segment from T to S. It's a line segment. Okay. End point. So this would be an end point here for the line segment, T, and then you have another end point of S. Here you go, a ray. Now earlier I talked about, I kind of gave you a glimpse of the ray. A ray is part of the line that starts at an endpoint and extends forever in the one direction. So I have 2 rays here. I have a ray that looks like this, and I have a ray that looks like this. So the top one is going to be what you see from here that way. Starting from T, going to S all the way forever. So that's the ray TS. The ray ST starts from S and it goes this way forever. Okay, that's the ray ST. Okay. Opposite rays are 2 rays that have a common endpoint and form a line. So opposite rays are going to look like we'll call this K. So the opposite rays are going to have a common endpoint, TS and K, TK, right? TK, because it has a common endpoint, and they are going in different directions. From T to K, T to S. Okay? Right. So that's what that looks like. Example 2. Draw and label each of the following. A segment with endpoints U and V. A line segment, which means it's just a part of a line, right? Part of a line, and it's U, V, right? So that would be A, B. Opposite rays with a common endpoint Q. So opposite rays with a common endpoint Q. Okay, does it actually give you the other 2 points? Okay, so Q, I don't know, we'll call this W, we'll call this A. So it would be Q, starting from Q in the A direction, 1 ray, starting from Q, going to the W direction, the other direction, right? Those two right there, okay? Postulates. What is a postulate? A postulate is something that is assumed to be correct, something that we're not going to prove, but something that is assumed to be correct, right? So, postulate 1-1-1. Through any 2 points, there is exactly one line. Okay, we already talked about that. Through any 2 points, so any 2 points, there's only one line. Okay. 1.1-2 or 1-1-1-2. Through any non-collinear points, are there 2 L's in collinear? 2 L's. Collinear. Okay, if they were collinear, that means they're all on one line. Okay, because it's now saying it's non-collinear, what that means is that there are 3 points that are not on the same line. So 3 points that are not on the same line, actually we already talked about this, defines a plane, okay? 1-1-3, if 2 points lie on a plane, then the line containing those 2 points lies in the plane, okay? So of those 3 non-collinear points, if you drew a line through the 2 of those points, that line has to lie within that plane that is defined by the 3 points. Okay? If you look at the picture, that kind of makes sense. Example number 3. Name a line that passes through 2 points. Okay? So it would be G and H, right? Name a line that passes through 2 points, G and H, right? I could have said F and G. I could have said F and H. Okay, let's go ahead and flip the page and move on to postulates. Intersection of lines and planes, 1-1-4. If 2 lines intersect, then they intersect in exactly 1 point. If 2 lines intersect, they intersect in exactly 1 point. Okay, you can't have a line, okay, that intersects in 2 points. How are these going to intersect in 2 points? This is going to go in this direction infinitely. It's going to go in that direction infinitely, right? So there's no way they meet again except for that 1 point. Can anybody tell me what we called 2 lines that did not meet at all? Did anybody know what that was called about those 2 lines? Unmute yourself and yell it out.
Parallel.
Parallel, correct. They're called parallel lines, right? If you remember, if you had 2 lines that do not meet, you called them parallel. What else did we talk about those parallel lines? We knew that what? If they were parallel, the slopes were the same. Does anybody remember that? No? Yeah. Okay. So we will learn about actually another way, except for being parallel, how 2 lines cannot meet. Okay? All right, now let's show you that, what it looks like. If I have 1 line that looks like this and 1 line that looks like this, okay, they're not going to meet, correct? Even though they're not parallel, one's going this way, one's going this way, they're not going to meet, right? We'll talk about that later. Okay? 1-1-5. If 2 planes intersect, then they intersect in exactly 1 line. Same concept. As far as 2 lines meeting at 1 point, 2 planes meet at 1 line. Okay? All right, are there any questions? Are there any questions of what we talked about? Okay. So your homework for today is 1-42. I am done teaching. So we have about what? Another 30, 40 minutes left. So I want you guys to